Oh, you mean number 5? Did you have these where you scroll?
On the test or the quiz? Oh, both. Oh, okay. The quiz, the average was, I think, 62 last quiz. Okay, and I think 6 of you did not take the quiz. Unless, I mean, I did not hear from any of you. I don't know what your reasons were. There was a mail that was sent out that there is a quiz on Thursday itself. And please don't flood our TAs with emails about, will there be a quiz on Thursday? There is a quiz every Thursday, including this Thursday. If it does not take place in the class, it will be on Blackboard. Okay? So this Thursday, most probably, it will take place in class. So be prepared for that. But there is a quiz every Thursday. Okay, so there's no reason for you not to know that there's a quiz.
Is the stuff that's on the quiz this Thursday going to be on the test?
Yes.
Oh.
Okay, so you should be prepared for the test by Thursday, right? You should be. And take the quiz as a motivation to do it before. To be prepared with it. Okay, some announcements about the exam. The exam takes place from 6 to 7 this Friday in Human Sciences building. In Human Sciences 226. It is there on the email that was sent out to you. Human Sciences 226. It's a bit hard to find, so it will be very much advised if you go there and find the room before you come for the test. Okay, don't walk in at 6 o'clock and assume that you'll be able to find the room. It's not that easy to find. So check it out sometime before Friday, and it will be a 1-hour test. You will have 15 problems, each problem around 8 points. So you can score up to 120 points. You get 13 of them right, you have 100 points. Okay, and you can score up to 120. 20 points are bonus. And you need to bring your own Scantrons. The Scantron that you need to bring is on that email. Okay, there's a copy of that Scantron on the email. So it's like the 5 answer option Scantron. You need to bring your own Scantrons. No Scantrons, no test. So make sure you bring your own Scantrons. Sorry?
Orange.
Yeah, orange Scantrons. Okay. And you need your ID card, pencils, and calculator. Any model of calculator works, but you will need a calculator for the test. Bring your ID cards too. Equation sheets will be provided, and the equation sheet that will be provided is on Blackboard. It's a thick booklet, so if you've never seen it before, you come to the exam and try to use it, you most probably won't be able to use it. Take a few minutes to look at it if you intend to use it. Okay. Before coming to the test, take a look at it. And I told you about the number of problems. Those of you who already told me that you have exam conflicts and cannot take the test on Friday, come and talk to me at the end of the class, okay? And I'll tell you where your test takes place. And this Wednesday and Thursday's tutoring session is going to be a review for the exam. So if you happen to be able to go to either of the Wednesday or Thursday, 6 o'clock tutoring session, regular time 6 to 7:30 in room 221, electrical engineering, it will be a complete review for the exam. Okay? And whatever we cover today and what will be covered on Thursday is a part of the exam. Okay. And that's Dr. Ken Griffin out there. He is a teach program consultant and a friend of mine. He's here to help me improve my teaching skills. And he's not here to observe you guys or put you in pressure, so don't worry about that camera out there. Okay. And any questions on ammeter, voltmeter, instrumentation that we covered last week? Okay, and then there are some, as I told you, I did not give you any sample problems last day, but there are some good problems in homework 3 on Blackboard, implementation, so I expect you to have solved that. first problem from today's sample problems. So today we're going to cover nodal and mesh analysis. There should be quite a few. So today we're going to cover nodal and mesh analysis. And these are direct applications of KCL and KVL, so I won't be spending too much time on them. But you have a number of problems on the sample problems I've given you. Okay? So I'll tell you what the difference is between this and KCL and KVL, or how you apply it, and then you can go ahead and get your practice. Okay? So your textbook dedicates an entire chapter on nodal analysis and mesh analysis, by the way. So nodal analysis, from the very name, what do you think it's going to be applying? KCL or KVL? KCL, because it's nodal analysis, right? You're analyzing a node. Okay? So KCL is the law that we apply at a node, right? And what does KCL state? Sum of currents at a node is equal to 0, right? That's why we're applying KCL, and nodal analysis is just a direct application of KCL. The only thing over here is that when you have a circuit and you can find the voltage, or you can find all the node voltages, you can then use nodal analysis instead of direct KCL. What that means is, let's say, how many complex nodes do we have in this circuit? One over here and one out here, right? So if I take this complex node to be a reference or to be a ground, okay? If I take that as ground, then I have left only one complex node, right? And if I take this as ground, what is the voltage at this point?
10 volts.
It's going to be 10 volts because this point is 10 volts above ground. And the voltage at this node is going to be?
2 volts.
2 volts. So I know the voltage at every node except for this particular node, right? And this is a typical nodal problem where you know the voltage is at every node. And now what we do is we apply KCL at the particular node where we want to find the voltage. Let's call this node A. And we represent all the currents in terms of node voltage. That's the only difference in KCL or in nodal analysis. Let's try and do that problem over here. So if you apply KCL at node A, in order to apply KCL at node A over here, we have to say that the sum of the currents in each of these branches is equal to 0. Right? Fine? Okay, so in order to say that the sum of the currents is equal to 0, first of all, we have to assume that some current is flowing in all of these three branches. So let's assume a direction for the current, this being I1, this being I2, and this being I3. That is, we just assume some random direction for the current. Okay. In this case, I just assume that all of the three currents are going out of the node, which is obviously a wrong assumption. And why is that? Because some current has to go into the node, right? Only then the other currents can come out. But it's just an assumption, as I said. You can assume all of the current going in. You can assume one of them going in, two of them coming out. No problem. Just I'm assuming the same directions, just so that when I do this I1 plus I2 plus I3 is equal to 0, all of my signs are same. If I assume that the current coming out of the node is taken as positive, I can say all of them are pluses, right? That's the only reason I chose them to be coming out or going in the same direction. You are welcome to choose whatever direction you want. Just make sure that you use the correct sign conventions. Okay? So this is just your KCL out here. So far you fine with me? Okay. So this is nothing new. This should not be anything new. It's just applying KCL over here. But now what the nodal analysis says is that we can write these currents, I1, I2, and I3 in terms of node voltages. And how would I write I1 in terms of voltages? How is I1 written in terms of voltages or resistance? V over R, and what is V?
10. Voltage is 10.
It's 10 over 3. How many of you agree on that? 2, 3? What about the rest of you? 4?
Voltage changes between the resistor, doesn't
Yeah.
It's not-
Changes? Or are you trying to say that the voltage across the resistor is not 10 volt? Okay. The voltage at this point is 10 volt. Voltage over here can be considered as VA. Let's just call it voltage at this node as A. Okay. So if this is node A, then the voltage over here is VA or some unknown voltage. Okay. It's not 10 volts across the 3 ohm. The voltage across 3 ohm is 10 minus VA. Okay. So how would I write the I1 current? Would it be 10 minus VA or would it be VA minus 10?
VA minus 10.
It would be VA minus 10. Current is going from the higher terminal to the lower terminal. Okay. We assume the direction of current I1 to be this. That means that it has to be VA minus 10. Is that clear? Because you're talking about a resistor, right? This has to be a positive and this has to be negative. Only then can the current flow in this direction. Okay? So it has to be VA minus 10 volt divided by your 3 ohm resistor. Okay? Fine? So how do you represent I2 now in terms of node voltage?
Oh.
So it's VA.
Would it be positive VA or negative VA?
Positive
It's positive VA. It's VA minus 0 volt divided by 4. Okay, it's VA minus 0 or VA divided by 4. Okay? Voltage over here is the higher, this is the higher potential, this is the lower potential, because that's the direction of current. Okay? And for I3, what is it going to be? VA minus 2 by 2. Okay? So this is what we call, or this is the only thing that you need to know about nodal analysis. It's just that you're representing all the unknown currents in terms of node voltages. And whenever you can do that, you can apply nodal analysis. Okay? Apart from that, it's just the same thing as KCL. Okay? So now we can say that the sum of these three is equal to 0 from here. And that gives us VA minus 4. We can go ahead and try solving that. So I'll try to get a pin that works. Sorry? And you can just find the LCM, cross multiply, and you have LCM is 12 out here. So you have 4 VA minus 40 volt plus 3 VA plus 12 VA divided by 12 is equal to 0, right? If 12 is your LCM, just straightforward math out there. So from here,
It should be 6 VA.
Yeah. Minus 2 plus
it's, I couldn't read my own handwriting. Sorry about that. Okay. It's 6 VA minus 12. Thank you. Okay. You have 4 plus 3, 13 VA is equal to, and this 12 goes out there, so it will be just taken off. It's equal to 52 volts, or VA is equal to, right? as I said, this is your first problem in your sample, which asks you to find VA. Whenever it says find VA, it's talking about VA with respect to ground. Okay. So in this case, you're already shown a ground. That's why it says of VA, or else it would have said find the voltage across 4 ohm. It's the same thing. If it says find the voltage across 4 ohm, it's still the same thing that you already did. So you have the voltage at A, node A. Now you can go ahead and find the power that's dissipated in the 10 volt and the 2 volts, which is what it asks for. Is this clear so far? Any questions on that? Okay. So whenever you have a problem like this, you go ahead and find the voltage. The first thing I suggest you do is you go ahead and try and find the currents and see if they make sense. Okay? If your voltage that you found over here, you need to check whether what you got is right. First of all, go and find this current. So I1, now that we have VA, I1 is going to be how much? Negative 2. Okay, negative makes a difference. Negative 2, I2 is going to be 1 amp, and I3 is going to be 1 amp. And what does this negative 2 mean? The direction that we chose was wrong. It means that the current is actually going in this direction. It's 2 amps flowing into the node. 1 amp is flowing in this branch, 1 amp is flowing in this branch. So that makes sense, right? 2 amp is going in, 2 amp is going out. So KCL holds. So you can say that at least the part that you've solved, you've at least solved this somewhat correctly. Okay? And another thing you can do in order to check your work is always, for any circuit, check that the sum of powers is equal to 0. This is what I said when I said about KCL and KVL. Always, once you have all the currents and voltages, find the power in each of the elements and sum them and check whether they add up to 0. If they add up to 0, you can be sure that what you did is right. So in this case, anyways, you're asked to find the voltage, or you're asked to find the power dissipated or supplied by these two sources. So let's find the power in all the elements, and then we'll see whether they sum to 0. And we'll also be able to find the power through these two, which is what we asked for. Okay? So what is the power across the 10 volt, or power supplied or dissipated by the 10 volt? How do you find power?
Current times voltage.
K is equal to VI or IV. And what is the voltage? 10 volt. And what is the current?
2 amps.
2 amp. This is the current that's flowing through the 10 volts, so it's 20 volts. Is it positive 20 volts or negative 20 volts? It's negative 20 volts because it's coming out of the positive terminal. Our current is going into the negative terminal. Okay? It's negative 20 volts, which means this 20 watt is being supplied. Okay? This negative just means it's being supplied. So if the answer doesn't give you negatives, like you have a multiple choice test, right? In the answer, if you might not have 20 watts, negative 20 watts, you might have 20 watts supplied. That's the answer, okay? Similarly, what is the power dissipated or supplied by the 3 ohm? How do you find that? I square R, or V times I, and in the case of resistor, if we know the current, we can replace this V as IR. That's where you come up with this I squared R, right? By now you should know all of this. So I'm not spending time on that. That's I squared R is the power across this. So the current is how much? 2 amps. 2 amps squared. Resistance is 3 ohm. So that's 4 times 12 volt. And is it going to be positive or negative? It's going to be positive. You don't have to do anything with that. You see a resistor, it's always going to be positive for a resistor. Current is, or power is always absorbed for a resistor, right? Okay, for the other resistor, the 4 ohm resistor, what is the power? 4 watts. 1 amp current, 1 amp squared times 4 ohm, that's 4 watt, okay? Through the other 2 ohm resistor, speak up. Yeah, 2 watts, you can just speak up. It's 2 watts. 8. I'm just doing this so because I know that if I ask you to do the sum of powers is equal to 0 at home, most probably you're not going to do it. So that's why I'm just doing it. So not for my practice, for your practice. Speak up. So the voltage or the power across the 2 volt is going to be 2 watts again. And is that going to be positive or negative in this case? It's going to be positive. Or this voltage source is in fact absorbing power. It's not supplying power. It's positive because the current is going into the positive terminal. It's absorbing power, and this is the only one which is supplying power. Okay? And now when you sum up all of these, you should get a 0. Okay? You have a negative 20. All of these should add up to positive 20. Okay? If they don't, then you know that what you found for your voltage is going to be wrong. Okay? Fine. So all of that, something we've done before, except for maybe writing the currents in terms of node voltages, and that's what nodal analysis is all about. So let's say in this case, if instead of having 2 volts over there, I had 2 amps. Now what would change? You still asked to find the voltage at node A. Okay? Just what we did. So what would change? You know the current. Thank you. Yes. You know this I3 already. Okay? You have the same equation. You apply KCL at this node over here. You have this equation, and all the currents you did not know, you will write them again in terms of node voltage. That's what nodal analysis is all about. But for the current which you already know, you don't have to write it in terms of any voltages and resistances. Okay? This is something many students again go ahead and do when there's no particular need for doing it. You already know that the current in this branch is 2 amps. So if I had assumed that the direction of my currents is this, I1, I2, and I3. This is how I assumed last time, right? So let me just assume the same direction. In this case, what is my I3 going to be? Is it going to be 2 amps? It's going to be negative 2 amps. Okay? It's going to be negative 2 amps. Again, that negative holds a lot of importance. That's just your next problem on your sample problems. And all of the other problems that you have out there till problem 5 are pretty much the same. They're just there for practice. Okay? If you do all of those, you definitely will get two problems right in your exam. So all the problems in this sample problem sheet out here, you will have one to two problems on nodal and mesh in the exam. Okay? You will either have nodal or you will have mesh problem. Nodal is what we just covered, straightforward case.
On the first problem that we did with the 2 volt source, since the current was flowing into that, should the signs be switched where it's negative on top and then positive on bottom?
No. Okay. So this is your battery, right? This is your battery with 2 volt, and it's already connected in the circuit like that. You cannot change any connections in the circuit. You cannot switch the connection of the battery. Which you can.
So I don't understand what the point of the battery is if it's absorbing
What
current.
is the point of the battery?
Yeah, because the battery's giving off voltage and current, correct? Or
Not always does the battery supply power, if that's what you're trying to say. In the circuit, there might be cases when this battery is not supplying power. You're saying that if the battery is not supplying, why is it there? Well, as I said, there might be cases like there's no question of why it's there. I'm not sure why it's there, okay, honestly. But I can tell you when you can see such a case. Like I said, when you're charging your mobile phone, your outlet is supplying power, your battery in the phone is absorbing power. Or in the case of your car, when it's charging, one of them is absorbing power. And this might be just a model of that. Okay? It's just a circuit we're trying to solve, which might be a model of the real world. And now, why do we have a battery which is absorbing? Well, as I said, you have cases when batteries do absorb, and we want phones to charge up and things like that, right? So that's the best I can answer that. Okay. So this is, as said, whenever you have a circuit where you can ground one of the nodes, and you will be able to find the voltages at every other node, you can apply nodal analysis. Okay? But let's look at the sixth problem on your paper out here. So till the fifth problem, they're all like that. Okay? When you put one of the nodes as a ground, you can find the voltages at every other node, except for the node you're trying to find the voltage at. But in this problem, so how many complex nodes do we have in this one? 2 again, okay. So let's just take the bottom one as a reference point, or as the ground. Okay. And whenever you're doing nodal analysis, if the ground is not already given to you, the first step is to set the ground. Okay. Set a point to ground, only then can you know the voltages at every other point. So if we set this as ground, what all voltages do you know? Do you know this voltage? What is that voltage? Hmm?
12.
It's 12 volts over here. How many of you agree in that?
Where?
Over here?
That's right there? Yeah, so.
One. How many of you agree in that? One? I heard somebody else say that. 2. That's it. What do the rest of you think? What's the voltage over here if I ground this?
0.
It's going to be 0 here. Okay, so that's a better answer. Actually, when you ground this, unless you know what's the current that's flowing through this 4 ohm, you cannot say what the voltage over here is going to be. Okay. If there is no current flowing through it, this is going to be 0 volt. They are both in the same potential. But if there is some current, you need to first find out what that current is. Then you can tell me what this voltage is. Okay. And you don't know this voltage, you definitely can't tell me what this is. Because if this is 10 volts, just say this is 10 volts, this is going to be 22 volts. If this is 5 volts, then this is going to be 17 volts. So this voltage is also dependent on what is over here. So when I ground this, I don't know this, or any of the voltage. Okay? So applying nodal analysis might be a bit of a problem because we have too many nodes and we don't know any of the node voltages. That's why we have something called mesh analysis, which comes into help when you have circuits like this, where you have too many nodes and you don't know the voltage of any of those. If you knew the voltage in 3 or 4 of them, we can find the voltage at the other 1 or 2. Okay? We can apply nodal at 2 points. Maybe applying it to more than 2 nodes might be too difficult. Okay? So mesh analysis is a direct application of KVL. Just as nodal was just KCL, straight applied at a node, mesh analysis is KVL, just that it's applied at a mesh now. And your KVL states that, what does your KVL state?
Summation of voltages equals 0.
Summation of voltage in a loop is equal to 0. But over here, when I'm talking about a mesh, what I mean is that mesh is a loop without a loop inside, which does not contain a loop within it. Okay? A loop which does not have a loop within it. That's what we call a mesh. So let's look at this circuit out here. How many loops do we have over here? 3 loops. We have one out here, another one over here, and this big loop over here, right? But in the case of mesh, we have only one and another one mesh, because this big loop contains 2 loops within it. Okay? So that cannot be considered as a mesh. So we have 2 meshes, but we have 3 loops. That's what we call mesh analysis. Whenever you're applying KVL,